one of my favorite quotes of Albert Einstein is, we can't solve our problems with the same kind of thinking that created our problems. And that's really kind of my impetus towards thinking more systematically versus kind of some of our conventional ad hoc methods. Albert Zent Yorgi, he won the Nobel Prize in physiology sometime in the 30s. And his quote is, discovery is seeing what everyone else has seen and thinking what nobody else has thought. Part of this fabric as well is, how can we see things that we're missing? A lot of things are hidden in plain sight, both problems and solutions. How can we identify them better?
Welcome to the Conversations on Applied AI podcast, where Justin Grammons and the team at Emerging Technologies North talk with experts in the fields of artificial intelligence and deep learning. In each episode, we cut through the hype and dive into how these technologies are being applied to real-world problems today. We hope that you find this episode educational and applicable to your industry, and connect with us to learn more about our organization at appliedai.mn. Enjoy.
Welcome, everyone, to the Conversations on Applied AI podcast. Today, we're talking with David Quimby. David is a principal at Innovation Radiation, where he practices systematic innovation, experimental design, and technology forecasting. He's a patented inventor in web architecture and user experience and co-founder of the Minnesota Change Management Network. He's earned a bachelor's degree in both mathematical and developmental economics at UCLA and a master's degree in organizational behavior and socio-technical systems at UC Berkeley. I've known David for years, but I actually found out some little-known facts about him recently. He's climbed Mount Whitney, done trekking in Thailand, photographic safaris in Kenya, sea kayaking in Alaska, and has traversed the U.S. and Canada by motorcycle. So that's amazing, David. All of this adventure, I know, will lead to some rich conversations as exploration and innovation go hand in hand. So thank you, David, for being on the podcast today.
Thanks, Justin. Really glad to be here. Well, hopefully we'll connect those dots around exploration and breaking through barriers. And thanks for doing the podcast, Justin. I really appreciate the way you build community in the Twin Cities. I like to say technical innovation is 80% social. So you really are a boost in that regard.
Thank you. Yeah, no, excited. I always learn something from everyone that's on here. So that's one of these things that I just enjoy, getting people on the show and sort of talking about artificial intelligence. And then, AI is such a broad topic, so it spans out into so many different areas. So systematic innovation, I know we'll end up connecting the dots to that. So I talked a little bit about, sort of where you're at today and the innovation, the systematic innovation work that you're doing, but maybe you can sort of lead us a little bit on a journey with regards to how you got to where you are.
Sure, thanks. And since we're going to be talking systematic innovation, I'll probably take a little bit of a systematic approach. I'm not sure I can do anything unsystematically, quite honestly. Probably a little bit compulsive in that regard. But I think of some of these disciplines as building blocks. There is a kind of a method to the madness. I like to say life is lived looking forward, not looking backward. But when I look backward, I kind of see, I was like, this is what I was doing. I was kind of scheming. I was kind of like putting together some building blocks to enable me to get to some destination, which I'm not really sure that I knew the destination. That's kind of this notion of intentional wandering, which will come back to systematic innovation. But I'll be maybe a little bit systematic about the building blocks that I see as forming this direction. I like to think that I've, to some degree, bridged the web and AI areas to some degree. And I think we've noticed there's a few members of our community that have had that same type of journey. So as I look backward, I almost see this kind of metacognitive orientation that I was headed forward in a direction. And I was kind of building some building blocks. I call it an interdisciplinary approach, or intellectual diversity, or call it what you will. So all I was ever going to be for the longest time was an architect. I took architectural design, architectural drafting courses in high school and that sort of thing. I went to the University of Minnesota. I was very fortunate to go through the pre-architecture program. I got into the architecture school. I kind of thought, wow, I've arrived. I'm in architecture school. I'm going to be an architect. And then I started realizing this is not ringing my chimes. And if I reflect on it, I think I was not getting kind of the theory. It seemed like ad hoc to me. And it just seemed like, this is good design. That's good design. The history was fascinating. Studying architectural history was absolutely fascinating. It was a great program. It wasn't really ringing my chimes from a theoretical perspective. And I said, well, I think I need to make an adjustment here. And so I actually had this kind of vague notion of I'd hitch up the wagons, head west. I was going to go to architecture school at UC Berkeley was my next sort of step in the process. And there was a guy there, his name's Christopher Alexander. He was doing something called design patterns, which we'll come to later. And you may have heard of him in the software engineering realm. He originated this whole concept of design patterns, which were not getting much traction in architectural design. He was a professor of environmental design at UC Berkeley, but there was a lot of resistance. There's a lot of pushback because, architectural design should be like ad hoc. It shouldn't be like systematic. But that was kind of in my genes at that time. And due to various circumstances, I ended up making a pivot after heading west. And I was going to work in California for a year, get residency. Tuition was a lot cheaper, that sort of thing. And I ended up pivoting down south and going to UCLA, switching my major, studying mathematical economics. So that was sort of another kind of node on the journey. Yeah, not switching up too much. You're not doing any zigzags, are we? But I'm very analytical. I'm very quantitative, but I also had an interest in the social sciences, which we'll see come out later in terms of like organizational behavior, things like that. My first job out of college was, I think I'll become a systems analyst. And I'd had a programming class or two, things like PL1 and Fortran. And I ended up being very fortunate pivoting into Bank of America, where it was actually it was a very large scale environment, largest data center in the world at that time up in San Francisco. And I started moving more in a systematic direction in that regard. They were looking for, interestingly enough, for broader background than purely, computer science, and talk about a confluence of events. And there you go, metacognitive orientation. How did I know and how did these events converge? But it was opportunistic, and I started getting more technical. And after working as a systems analyst for a while, which I guess these days we'd probably call it more like a business analyst or business architect, then I pivoted into even more technical, getting into software engineering, developed some pretty large systems at Bank of America, helped develop, getting into large scale system development. Then my next pivot, getting itchy for the next move, I pivoted over to Deloitte Consulting. And what I got to do there based on my background was really mostly focused on what I'd call technical and economic feasibility analysis, mostly for the U.S. Air Force, but looking at feasibility studies for very large scale development efforts and kind of adding that longer term sort of orientation perspective, that sort of thing. And by this time, after a couple of years doing that, I was starting to see this tension between the technical side and the organizational side, or the social and cultural side. And I thought, where do the twain meet? Are they meshing? Are they coming together? And that sort of like became my focus. And so pretty soon it's time for another pivot, right? And I decided I wanted to go study organizational behavior and what they called socio-technical systems. And I was fortunate to get into UC Berkeley and do that program. Technically, it was an MBA program, but I like to think of it as a master's program in organizational behavior. And so added that node, we're kind of building the building blocks. And again, I'm not sure, exactly where things are headed, but I'm kind of having this vague notion on the horizon and kind of pulling in building blocks to move in that direction. And after UC Berkeley, my first job was over at Stanford Research Institute as a technology analyst doing technology forecasting. And my focus was in emerging technologies, really oriented towards artificial intelligence, believe it or not, of all things. So that would have been like early 90s. And my orientation was what we'd call knowledge-based systems or expert systems, inference engines, whatever you might call them. We were also getting early in neural networks at that time, and then speech recognition and natural language. And as you may know, SRI is one of the origins of technologies like Siri. It was really a real leader in speech recognition and some of that stuff at the time. I also had the good fortune to collaborate with a guy named Doug Engelbart at SRI, and there the focus was social computing and what was then called groupware and eventually became social media. And he's the inventor of the graphical user interface and real orientation towards what I'd call human-centric design. I almost think of him as really one of the early pioneers in that whole notion. And he had led something at SRI called the Augmentation Research Center. He was real interested in augmenting human intellect, was kind of his focus. So all these nodes, hopefully the breadcrumb trail is leading closer to where we stand today. The next pivot was having an opportunity to go back to work at Bank of America with some previous colleagues and working in what was kind of an autonomous business unit, sort of an exotic business function, large multi-entity transactions that were like really complex and needed a little more advanced technology. And I had the opportunity to bring some advanced technology in there and serve as technical and architectural lead to introduce things like object-oriented programming systems and client-server architecture. That sort of begins my segue toward the web. The orientation towards client-server architecture was kind of like a natural pivot into web architecture, and then combining that with human-centric design is what led me to thinking about problems on the web and what was next. And at that point, that's really the last job I've really had. I've done some contract work, at Best Buy in emerging technologies and around product discovery, that sort of thing. But I really set off on this journey, unknown to me, but I call myself an accidental inventor. I invented a web presentation technology or a tool for web presentation, and it kind of combined the background in client-server architecture with the whole notion of architectural design and moved us into this era of inventing and realizing, there was like a method to the invention. And maybe I'll take a pause there. Hopefully that wasn't too longish, but it gave us a little sense of the building blocks, and that'll kind of bring us up to this whole notion of what is systematic innovation and how does it apply to AI, if that makes sense.
Yeah, no, it does. It does. A lot of vocabulary, a lot of terms I think we have to unpack here as we're sort of talking through this. We've got things around metacognitive orientation, intellectual diversity. But as you're getting to systematic innovation, I think that is a great place for us to start, because that seems to be sort of at the core, the things that you're focused on today. I think probably a lot of our listeners, maybe they hear the words systematic and innovation and they try to put those two together, and maybe you can help us understand what that means when we're talking about systematic innovation.
Absolutely. Well pointed. So the first thing I want to do maybe is offer a couple of quotes just for perspective, because they kind of set the stage. One of my favorite quotes of Albert Einstein is, "We can't solve our problems with the same kind of thinking that created our problems." And that's really kind of my impetus towards thinking more systematically versus kind of some of our conventional, ad hoc methods. And then I'll mention a quote from an inventor who's much more obscure. His name is Albert Zent György, if I'm getting that right. I think he was Hungarian. He won the Nobel Prize in physiology sometime in the 30s. And his quote is, "Discovery is seeing what everyone else has seen and thinking what nobody else has thought." And that's part of this fabric as well, as how can we see things that we're missing? A lot of things are hidden in plain sight. Both problems and solutions are hidden in plain sight. So how can we identify them better, articulate them better? If that makes sense, it's kind of a segue.
Yeah. And so there's an approach here that you're saying there's like a systematic approach for us to solve our problems with a different kind of thinking?
Absolutely. That's kind of, setting the stage. To get a little more particular, I'd say systematic innovation is a more structured approach to generating and implementing, ultimately, I'd say, product and service value. Doesn't mean it doesn't apply to non-industrial domains. We'll get into that realm, but maybe for starters, it's a structured approach for generating product and service value that may be unseen. I like to say, unlike a spontaneous creativity or ad hoc brainstorming, which they can be effective, there's nothing wrong with them. It's just, are we being as effective as possible? Systematic innovation uses more deliberate principles, methodologies, and frameworks to be more consistent about producing meaningful and impactful value, if that helps. And I'll introduce a couple terms here, and then I'll try to simplify them. You'll hear me using, and they're built into my method, using a lot of terms, and they end up tying back to classical philosophy. I think there's more need for philosophy in AI, in innovation, in tech in general. I think STEM needs more philosophy in it. And I didn't realize, I wasn't deliberately incorporating these capabilities into my method. I kind of realized retroactively that, I was using these capabilities. I'd somehow learned them somewhere along the way, and I'd kind of built them into my way of thinking, but I wasn't consciously building a method that used these capabilities. The two terms I'll mention here are ontology and morphology. And I'm going to say they come from, ontology comes from Aristotle, and he was, of course, a student of Socrates, and morphology comes from Plato, who was a student of Aristotle. And ontology simply means, in the simplest term, we could use it. I mean, there's more nature, more texture to it, but we can think of it simply as categories. And how do we look at information through categories and existence through categories? Morphology, in its simplest terms, just means forms. And I find these to be useful levers for thinking systematically. Another thing I'd mention about systematic innovation is it's a stepwise process versus, say, an event, like an explosive event of idea occurs here. It's very deliberate. It's a stepwise process. We might say, even kind of a journey. And pick your stages, and they may vary depending on the method, but it's a deliberate stepwise process. And I'd also say it's relatively problem focused. And that may sound like, well, conventional, but I think it's differentiated relative to conventional problem solving. I think we tend to sometimes slide over the problem definition, and it prevents us from really solving the problem or even solving the right problem. It's very expensive to solve the wrong problem. And I think systematic innovation is better about being very problem focused and not proceeding until we know we have a problem definition. And what I would like to say even further, unambiguous problem definition. And I could give a couple of examples of methods that are out there if that might help.
Yeah, for sure. I think you said something key there. Like, it sounds like at its crux, we need to make sure that that there is a problem there, I guess, right? Was what you're saying. I mean, I talk to a lot of companies that are just building AI for the sake of building AI or trying to implement a technology solution when actually the old tried and true method in some ways continues to work just fine. And sometimes you're trying to fit a square peg into a round hole. And what can be difficult is not only that maybe the technology is there and it's available, but there is no return on investment, right? There is no clear path forward of like, doing this is actually going to save the company more amount of money. And so you end up kind of pushing a rock up a hill and everything ends up kind of going sideways on these projects. But yeah, that's kind of what you're saying is think more of a systematic approach. There was some examples that you were going to share.
Well, and I think, again, you're very pointed in your perspective, Justin, in terms of, it almost sounds like hammer nail. As technologists, we love to use technology. We love to point that technology in any direction that may work versus almost like working backward, start from the problem. And for some technologists, it's a real tough thing to do. It takes a lot of discipline to say, we aren't moving off the starting line until we have a problem and until we all agree on the problem and the problem definition. And then we'll work backwards from there toward a solution. But we have to agree that we have a problem first. So anyway, just that concept right there, I want to point out kind of as we go, that's a systematic thought that you just expressed and that we just kind of agreed on because we're looking at the large system, a principle of systems engineering. And of course, there's a lot of systems engineering that comes into systematic innovation. Every system exists in a super system. Systems are composed of subsystems. They operate within a super system. And in this case, we're talking about a systematic approach to the holistic situation, the problem and the solution, the social or organizational context, and the technical approach that we're going to take to solving it. And that's very much systematic thinking there, just saying we're going to start with having a problem before we even move forward. Okay, so a couple examples that I'll mention just in case they're kind of like landing points for the audience to explore. An author named Rias van Wyk had a method that I was kind of exploring in this realm, in this genre, and he wrote a book on the core theory of technology. He was looking at like, what is technology broadly, what cuts across all technologies, and he stumbled across a presentation I was giving in one of the technical communities where I'd done this view. I guess I called it a palette. I didn't call it the Quimby palette. He called it the Quimby palette in his book, interestingly enough. And I kind of mentioned and connected the dots among some of these genres. And I said, I think it'd be actually a systematic innovation endeavor to think about these things systematically and connect the dots among some of them. But one of them I've already mentioned, Design Patterns by Christopher Alexander, where he's looking at, kind of the combination between modular construction or modular approach to things, and yet we can still generate a profusion of complexity with a modular approach, but we still have kind of an underlying backbone, that sort of thing. Maybe the essential idea under Design Patterns. Fascinating field. Christopher Alexander, fascinating guy, might be interesting to the audience. Another one that comes to mind is lateral thinking. Edward de Bono, kind of one of those creative thinking techniques where you look at, well, what are the adjacent ideas? What's to the right? What's to the left? What's ahead? What's behind? Again, fairly deliberate, fairly specific. There's a technique called TRIZ or TRIZ. It's a Russian acronym. It stands for Theory of Inventive Problem Solving. It was originated by a Russian, imagine that, probably in the 60s, maybe even 70s. He looked at the Russian patent database, took all the patents and distilled from them what he called the inventive principles. One last one I'll mention because it lands pretty close to my method is called a morphological analysis, developed or originated by a guy named Fritz Zwicky. Interestingly enough, he's a Swiss astronomer, was a Swiss astronomer, and he was looking at kind of like the way I defined morphology earlier, forms. He's looking at like, how do we look at forms? How do we identify things in terms of their forms? How do we pivot off different forms to produce new forms, things like that. And so those are maybe a few little more practical views on types of systematic innovation that are currently in use.
Yeah, no, this is great. We'll make sure we put all these links to these books here in the liner notes. So if anyone that's listening or whatever, I'll get these there so people can go off and explore on their own.
It's a little bit of a deluge, I suppose. Like I said, we got a long way to go, a short time to get there. So, and maybe a couple of things I'll mention at this point, because the audience might be interested in, well, like, so what? What is the benefit or what's the advantage or the differentiation? And I think I've maybe intuited to some degree. By the way, another thing I might mention for helpful clarification is we kind of know what innovation means, or we have ideas of what does innovation mean. And we have some ideas around like, what does systematic mean? And to a large degree, we are just combining those terms. And we're saying, okay, we're doing innovation, but we're doing it systematically. And that may sound like a paradox or even like oxymoron. I'd like to think of it as a synthesis of two different types of things that we're kind of meshing together. And I'll be getting to synthesis when I talk about my method of systematic innovation. I'll also mention that a lot of conventional innovation might actually be subconsciously systematic when we take things apart. I've had the experience of taking apart, like, for example, I looked at the graphical user interface and I said, well, if Doug Engelbart was such a freaking genius, what was the systematic innovation or the systematic method? And in my approach, I'll be talking about opposing forces. And in retrospect, I was able to look at the graphical user interface and see that it solved a contradiction, or it identified and solved a set of opposing forces. Now, I'm not for a minute saying, and I knew I had the good fortune to know Doug and collaborate with him. And I'm not saying he thought about the graphical user interface systematically in the way I'm going to talk about it anyway. Doesn't mean that he wasn't subconsciously systematic. And that maybe gets into this, what I'm really talking about when I talk about metacognitive, is I'm really talking about beyond the conscious, maybe not sub, but super conscious. And anyway, so a lot of conventional innovation may actually in retrospect be systematic. Sometimes when I talk to entrepreneurs, I look at their idea and I can actually decode it into the contradiction that they solve, the way they're actually thinking systematically, even though they're not conscious about doing it. And I guess my segue would be, doesn't mean we can't become more systematic in our way of thinking. And what I think that enables us to do is become more continuous in innovation. It enables us to become more distributed. I think innovation can go much more broadly across the organization than it does. I think those who are tasked with innovation can be more continuous or more predictable to some degree with innovation. I think systematic innovation potentially produces more disruptive innovation or more radical or divergent innovation. And I also think it enables us to be more collaborative because we have a more kind of codified concept of what is the problem and how are we approaching the solution.
So quick question here because we are going to start talking a little bit more about some of the AI concepts, right? We're going to talk about alignment and RAG and stuff like that. But
yep.
You got me thinking, are there any cases where you don't want to use this?
Wow, that's interesting. I've been asked the question, like, for example, what if it takes too long? And my experience has been, to a large degree, maybe it's kind of a platitude, but there's never time to do it right. There's always time to do it over or do it again. And, just like, as you know, it's very expensive to solve the wrong problem. And so I guess that would be a possible objection or a possible resistance as well. It's too formal. It takes too long. I'm skeptical about that possible objection. And you got me thinking about, well, what other reasons? That's the only one that jumps to mind as a possible concern is, well, do we really have time to be formal or systematic?
Yeah, I guess that's what I was just kind of getting at. You're saying this should be used everywhere. And are there particular cases where this idea of just a random walk that you would just kind of experiment and try around with other stuff, there have to be some sort of use cases out there where potentially it would be fine, right? And some of it is like if the company has unlimited budget, they don't have any goals really set, like it's just kind of exploration for the sake of exploration. Maybe that's what I'm saying.
Well, that kind of gets me into this hybrid that I call intentional wandering and how the two come together. It comes in waves, it unfolds in layers. One thing I should be careful to articulate, and some of this will come out as I talk a little bit more about the specific method that I've kind of developed, is it's not only systematic. I'm actually combining elements of randomness. And how do you do that? That's almost like a third level. It's almost like, well, we don't want to be purely random, but we don't want to be purely systematic either. We also want to introduce elements of randomness or non-determination or that sort of thing. And I'm going to say at a meta level, we got Russian dolls here, one within another. I'm going to say at a meta level, the concept of integrating systematic and random is a systematic process. And I'd like to think I've done that. It's kind of a layered architecture.
Yeah, sure.
But there is a random element in it. So
yeah. Well, it's the song by Rush. It's like even if you haven't made a choice, you still made a choice. I think it's Free Will. I think it's a song by Rush. So it's like even if you haven't made a choice, you still made a choice. So that's what you're saying is like basically combining these together. You've actually created a new systematic approach. So let's talk about your systematic approach.
I guess I'll be a little bit systematic in explaining a bit, hopefully fairly compressed. I solved a contradiction, I like to say, early in the 21st century. And what I saw, I was looking at the web, and I'd had some background, as I mentioned, with Doug Engelbart, and I was thinking, human-centric design, user-centric design, and I'm going, what are the problems in the web? And search was being solved at that time, and I saw a problem with navigation or presentation. And the underlying forces that I saw being kind of in tension were the notion of web content is very granular, it's very, very fluid, very modular, and yet how do we view content in streams? It's this clunky kind of point and click. How do we put these objects together? And on the other hand, we could view animation and video and movies in streaming format, but it wasn't very modular. And I said, well, I want some combination of both. I think that would be like the next generation of being able to do content on the web. And of course, everybody told me, well, that's impossible. And I said, yeah, you're probably right, but it's worth trying. And I just kind of imposed my architectural will on the situation. And that's where architectural, design and architectural thinking kind of came in. And lo and behold, I was able to solve the problem, and I was able to reduce it to practice. And I did get some patents on it. I have four patents in web presentation, web architecture, and it's being used in large-scale e-commerce. To this day, I have some licenses out there. And it comes down to this notion of these opposing forces. But all I was trying to do is solve the problem. I was not trying to invent an invention method, but sometime after that, upon reflection, again, this looking backward, kind of this retroactive perspective, I realized there's a method here. And then after, for some time after like realizing, there was a method to this invention, I realized, well, it has other applications in the technical realm. And then after a while, I realized, it not only has other applications in the technical realm, it can apply to domains like the organizational domain, behavioral problems, social problems, that sort of thing. I actually recently had a chapter on applying this method in the realm of social change. And as you know, I've got that interest and background in socio-technical systems and change management and some of that kind of stuff. At some point, again, as it's kind of gradually being unraveled, unfolded, it unfolds in layers, it comes in waves. It's kind of this journey meme. I'm gradually uncovering these layers. At some point, I realize, wait a minute, this is like one of those methods of systematic innovation, which I was like, had been brought to my attention. And I realized it fit in that genre thing, which led me to the quote unquote Quimby palette and seeing, this is one of these methods. It fits in this realm of systematic innovation. And then the last elbow joint I'll mention is I realized retroactively, kind of metacognitively, I guess, that I had tied together these aspects of classical philosophy I got from Socrates, the dialectic, or opposing forces, thesis, antithesis, synthesis. That's a deep subject. We probably won't have time to go into it real deep, but just the notion of two opposing ideas and then coming up with an idea that combines the best of both of those ideas. It's not a compromise. It's not an optimization. It's a actual resolution of the, yep, exactly, net new and best of both worlds kind of thing. And then I'd also realized I'd been incorporating Aristotle's ontology or categories and Plato's morphology or forms. And so again, accidentally discovering that this method is rooted in ancient classical philosophy, and it ties to this modern genre of systematic innovation methods. And it does trigger and leverage this metacognitive orientation or unleash the subconscious, not just purely conscious, and also combining linear thinking and nonlinear thinking, also combining a systematic aspect and a random aspect.
Yeah, that's cool. I like this approach that you're thinking about. There's a lot of different ways to go with this, but I want to try and bring it back to AI with regards to how you can tie systematic innovation to AI. So, I'm just thinking about a more practical use, right? So I'm building an AI system, for example, a couple different layers here. One is how would I use systematic innovation in what I build? but also like maybe what are some core philosophies or core principles that I could be bringing from this, I guess, from this philosophy into the systems that you build in AI, right? Whether it be, you and I talked about, before we got on the show here about this alignment problem, right? For example, these things hallucinate. So are there certain techniques or practices that you have seen that you're like, aha, like if we apply systematic innovation to this particular challenge we have with AI, this will help us solve it?
Beautiful. Again, right, spot on, Justin. Yeah, where do these two things come together? And it's almost like an ideal fusion in a way. And again, I approach these things independently. I didn't set out to develop a method that could like leverage AI or anything. It's all a matter of like, what do you see when you get there? And again, I've got some background in AI, ancient times. And then as AI has like been coming to the surface, of course, I can't resist like starting to dabble with it. And at some point I realized, oh yeah, there's this whole alignment thing. They hallucinate. They're not totally accurate. By the way, wouldn't it be nice to use them for innovation and for creative thinking and those sorts of things? But it's very nonlinear. By the way, as a side point, not exactly in this direction, I did think about applying systematic innovation to the contradictions in AI. And I had an article published in a journal on operations research looking at it from that perspective. That's one way of looking at the intersection of systematic innovation and AI, and particularly from the perspective of how can systematic innovation contribute to AI. In this sense, I'm thinking more about, yes, this alignment problem, and they hallucinate, and how do we discipline them? How do we make them like more useful in that regard? And we've sort of come across these approaches like retrieval augmented generation. And I think of course, with OpenAI, we have the custom GPTs. And also part of the equation is the human in the loop and the prompt engineering. How do we prompt these things? And we get better and better about prompting them and chain of thought and some of these things to keep them between the guardrails. And the irony is, it's a contradiction. And this is one of the contradictions I wrote about, the contradiction between generativity and what I call fidelity, keeping the thing between the guardrails. And we don't have any way inherent, at least that I know of, or maybe you know of, but that we can inherently, because they're neural networks, they're neural network architectures. They do what they do. They're trillions, billions of variables. And we, at this point, they don't really show us their work. And we don't have any internal mechanisms for keeping them between the guardrails, but we're using some of these things like better prompt engineering, chain of thought, breaking things down stepwise, retrieval augmented generation using external knowledge bases, that sort of thing. And so at a certain point, it occurred to me, well, gee, could I use systematic innovation as that component? And here's where I'm going to revert to the quote by Albert Einstein. I think there's two parts to this approach. One is, okay, we've got to use things like retrieval augmented generation, better prompt engineering, but I think we also need to think differently. I think conventional human thinking isn't going to be the best answer in terms of our approach to keeping the AI between the guardrails. I want to take a swing at applying a different way of thinking, applying systematic innovation to this challenge. And so I trained a custom GPT using my method. And kudos, shout out to my colleague, Dan Olson, who I know from Best Buy, and we're co-founders on the Minnesota Change Management Network, et cetera, and shared the vision with me. And he's a real builder and doer. He can put these things together seamlessly, and really glad to have him as a longtime colleague and had the same vision. So we built a custom GPT that operates the method.
That's fabulous. That's fabulous. And so you're satisfied with what you ended up getting out of this?
Justin, that's the part that's really interesting. This, especially when we're experiencing all the hallucination we can tend to experience. To me, it was profound how well I was able to train it in my method. And the interesting thing that Dan Olson says is, he likes to say, now I have a muse. The AI knows my method, and I can interact with my custom GPT on my method. I now have a muse. We interact, and I'm going to say it's even to some degree suggested, maybe extended it, maybe filled some gaps in it. We're actually seeing, through the process of interacting with it, where it can not only apply the method, and it comes up because it's connected, of course, to a broader LLM, it can operate on domains that aren't built into the training I gave it. That's a pretty interesting, aspect as well, is it's got the whole world at its disposal, and it applies systematic innovation to it because it knows the way to do it. And it's not limited to the information that I used in the training, like example contradictions that I might have given it, that sort of thing. So that's kind of the interesting combination there. And I've been very surprised and pleased with how well it seems to be able to operate the method.
Wow. So that's truly what you're talking about with regards to just the different approaches. And I think you and I have probably seen this, taking approaches from a different industry and applying it to something else where people get in their blinders. They just think this is the way this has always been done. And sometimes you can come in and say, well, actually, they do it this way in banking and finance. Have you thought about doing it this, so kind of bringing those approaches. So this idea that you have this framework, this higher level metacognitive framework that you can apply, and now you have essentially trained an AI on that, that's super powerful to be able to point that at other things. And it kind of also goes back to, I was meeting with a potential customer the other day, and a lot of them they're thinking of these same ideas. Like, okay, I want to throw a bunch of my documents into a retrieval augmented generation system or whatever, an LLM. And then I want to be able to have people come in and, ask it questions. And what kind of dawned on me was, okay, that's level one and that's where everyone's at. But, the thing that I think is more interesting is ask the LLM, how do I solve this problem? And not to say that you're going to get the right answer, but I'm continually trying to push it and say, use it for creativity, right? Because oftentimes it may not be the first, second, third, or fourth answer, but there might be a fifth answer down there as I keep iterating and prompting with it and saying, well, what do you think about this? What do you think about this? It has the opportunity for us to unlock these different paths that we wouldn't go down if we were just sitting there isolated. And maybe even kind of getting metaphysical now, you throw a bunch of humans together. I always say we're a bunch of, carbon-based people, but now there's the silicon-based thing that is ultimately at its core going to take a different approach and might actually end up sending you off on a different path that you even wouldn't have gotten if you were brainstorming ideas with another human. I don't know, just sort of throwing that out there.
No, very, very pertinent. All across the board, Justin. I think a lot of things goes in many directions. This whole notion of how are we using AI? We're only at the beginning. And Andrew Eklund had a real interesting presentation last week on the notion of we're using AI to do things like note-taking and find the action items, in this transcript and things like that. I think the meme or the cartoon was the user asking Albert Einstein to take some notes for him. And Albert Einstein's over here going, well, yeah, but how about I solve like quantum computing or do something like pertinent or important? And I think if you look at that spectrum, I'm trying to nudge forward on that spectrum. And how do we use AI more powerfully for things like creative thinking and product discovery and some of that territory? And by the way, combining it with the notion of, I think we need, at the front end, more powerful human methods that we're using to complement the AI. So
there you go. So you can basically, it's one thing just to throw it out there and say, do some stuff, but you're actually taking the best of both worlds is kind of basically what you were saying, taking these two approaches and now you have a new way to do it.
You got it. Yeah, that's kind of the idea. And it's a fusion at some level. It's a synthesis at some level. And how do we take the best of both these things? I guess I would say, well, obviously, when I kind of saw the light and said, oh, gee, I should build a custom GPT, I'm just dabbling with it, and I can't tell you what exactly, lit the light bulb, but at a certain, because it wasn't where I had it. I didn't start out to apply AI to my systematic innovation method. I was just dabbling in the AI stuff. And at some point I kind of go, wait a minute, could the two of these pieces come together? And certainly that's kind of when the light went on and I said, well, I could actually extend and empower the SI method by attaching it to AI. And at the same time, AI has this alignment problem. And so it's really like best of both worlds. SI can align the AI can extend and empower the SI. And I think that combination, it's obviously an artistic event to combine them, but that fusion or that combination is better than either one alone. SI combined with AI is better than AI without it or random human techniques. SI with AI on the back end is much more powerful than me doing SI and my old manual methods. I've kind of gotten bored with the old manual methods, if that makes any sense.
No, it does. It does. I think AI makes things fun again in a lot of ways, and it allows you to be able to experiment around with it. I took a note earlier that you're an accidental inventor, which I think that everything you just said right there it basically sums up there, because you were looking at building something or looking at a certain way to do it, and you actually invented kind of a new method to bring these things together. I think, as we kind of wind down the conversation, you had mentioned something about socio-technical systems, and I think I did want to touch on that because coming up through engineering and building software for 25 years, what I've learned, and I didn't know this at the beginning, right? And I think many software engineers don't understand, and even architects that are just in their own technical world, it is so much more than just fingers on keyboards and writing code, right? It's the whole human interaction with the thing that you're building, and not even within your team. Yeah, that's just one piece, right? You've got product managers and product designers and all this type of stuff. There's this whole socio piece there, but then even out to the customers, right? So, this idea of, I had never really put a term to it, but I feel like, is that what you're talking about when you talk about these socio-technical systems? Kind of the idea of bringing technology, and I don't know if socio means sociology or society, but is that kind of what you're getting at with some of these things?
Very, very pertinent. Sorry, we've covered some of these kinds of things fast and thin, but yeah, very, very pertinent. What I'm saying is, when I talk about a socio-technical system, is it's got both social and technical elements, and there is no system that's purely technical. It's just not. These things don't emerge from vacuums, so they're always built with, I like to say, technical innovation is a socio-technical system. It's like all the social elements, organizing the humans, getting them together on the same page. It's all a system. If the system is going to be a whole product, it's going to emerge from a holistic socio-technical system where those parts are better integrated. And then going back to Doug Engelbart and human-centric design and that sort of thing, that social or human aspect of any particular application has those aspects to it. And in a way, it maps to, again, it's a dichotomy. We're back to dualistic philosophy and the dialectic or thesis antithesis. And it kind of maps to this whole notion of systematic and random. And I think I've conveyed, you've been careful to draw out in me this aspect of systematic innovation isn't only systematic. It's not like formulaic. It's not like just deterministic. It's really this combination, this dance or fusion or integration of the systematic and random aspects. And likewise, a socio-technical system is kind of a combination of those sort of aspects that we'd typically consider to be maybe linear and nonlinear. The social is the more nonlinear part, the more amorphous part, and the linear being the more well-formed part, I guess.
For sure. Yeah, no, you can't have one without the other. They basically are intertwined with each other. And the other thing to sort of kind of wrap it up too, that was in my head as you were talking. So you talk about design patterns, and it's one of those things that I kind of backed into as well. I wrote a lot of software, and then over time I realized, and then I kind of opened up the book, this Gang of Four book that,
Yeah, there you go.
And that's like, oh, I was doing this. Oh, and there's another pattern there. There's another pattern there. And then you start to realize the philosophy behind it and why it was done and all that type of stuff, and then like the power in it. And I think it's fascinating that it sounds to me like, you mentioned, Christopher Alexander, right? I wasn't exactly sure. Now, I think the guys who kind of wrote, there's like Grady Booch and some of these other guys who sort of like did that. But it makes a lot of sense to me that it actually came out of, you said it came out of more of the metaphysical or the human world, not so much from a technical programming engineering standpoint.
Yeah, architectural design. And by the way, Gang of Four, that crowd got theirs. That was a progression from the Christopher Alexander stuff. He was at the root of it. He was kind of at the origin of it, trying to apply it to architectural design, but at a certain point he pivoted. Oh, pivot,
Yeah.
That's the nature of the beast, paying attention to, well, where are we getting traction and where are we not getting traction? So yeah, there is that breadcrumb. And by the way, I also want to point out to you, Justin, you were doing it, and then you found out there was the method.
Yeah.
And so again, I say a lot of times we're maybe operating in this subconscious way systematically. Well, what if we were more conscious about it? Just like I say, well, I was kind of subconsciously, using some of these classical philosophy disciplines and some of that kind of stuff. And I think a lot of times we are kind of under the covers thinking systematically. And I'm just nudging us towards, let's be more deliberate about it. And then, by the way, can we also be deliberate about artistic combinations of the random and the systematic? Of course, we don't want to be totally deterministic. We want undeterministic elements. That's the nature of innovation, is producing something new. And can we produce systematic catalysts for producing artistic combinations of the systematic and the random elements?
Yeah, it's fabulous.
Heavy stuff, huh?
Yeah, well, back to what I said at the beginning, I always learn something with these talks when I talk to people for, 50 minutes to an hour or so. To wrap this up, David, how can people get a hold of you? What's the best way for them to find you?
My website is innovationradiation.com.
Okay.
And there's plenty of propaganda and rhetoric out there. Just because it's rhetoric doesn't mean it's not valid. And then also, if they want to take a swing at Matrix Mentor, is the custom GPT that I built with Dan Olson. And they can find it at Bitly. It's right now at Bitly, bit.ly/Matrix Mentor.
Nice. Okay. I'll have these links in the liner notes and in the transcripts and everything like that. So It's been fabulous, David. I appreciate the time. We got to have you back because, yes, 1 hour is not enough for sure for us to talk through this stuff. We just scratched the surface. I think there's a lot of different ways we could go, but I appreciate you taking the time and coming on the program today and sharing your knowledge about systematic innovation and how you're applying it to AI today. It's been a great conversation.
Thank you, Justin. Thanks for building community. Really appreciate it.
You've listened to another episode of the Conversations on Applied AI podcast. We hope you are eager to learn more about applying artificial intelligence and deep learning within your organization. You can visit us at appliedai.mn to keep up to date on our events and connect with our amazing community. Please don't hesitate to reach out to Justin at appliedai.mn if you are interested in participating in a future episode. Thank you for listening.